Now let's apply what we've learned about sets, subsets, unions, intersections, and complements in Venn diagrams to information given in surveys. Suppose we surveyed 48 students at a university, and of the 48 students, half were receiving federal financial aid. The results from the survey found that 5 had Pell Grants, 14 participated in the college work-study program, 4 had TOPS scholarships, 2 had top scholarship and participated in the work-study, and then we have the additional information that those who had Pell Grants had no other federal aid. Based on this information, we need to answer the questions: how many of the 48 students surveyed had no federal aid, more than one of these 3 forms of aid, federal aid other than those 3 forms, a top scholarship or a work study, exactly one of these 3 forms of aid, and no more than one of these 3 forms of aid. In order to answer all these questions efficiently, instead of dealing with them one at a time, we're going to first spend a bit of time at the beginning to make a helpful Venn diagram, and then once we have a correctly labeled Venn diagram, we'll be able to find the answers to all these problems efficiently. So as you begin your Venn diagram, you first need to think, what's the universe of discourse? So some question has been posed to certain individuals. How would you describe the individuals questioned? Read through the first few sentences of this example. So all the questions surveyed were 48 students at a university. And to be specific, they asked the question, who is receiving federal aid? That was the main question. Now they told us half of those were receiving. So of the 48 students that they asked, 24 had federal aid and 24 had no federal aid. Now, of the students who said, I do have federal aid, we have this additional information. So since we know 24 had no federal aid, let's focus on these 24 who did have federal aid. So our universe of discourse U is the 24 students surveyed who received federal financial aid. Because we already know everything about the 24 students who did not. There's no extra information that needs to be teased out. So our universe of discourse is the 24 students who receive federal financial aid. So we'll draw that here. So this is our U. And we know whatever I write in here, in all, there should be 24 people at the very end of things. So let's go through the information given and see what types of federal aid were mentioned. The first one was the Pell Grant. Let's let P be Pell Grant recipients. Next is the college work study. So let's let W be college work study, students who have that. Okay, continuing, next we see TOPS mentioned. And then they mention work study again, we already have that listed. And they do tell us this very interesting piece of information about those with Pell Grants. Those who had Pell Grants had no other federal aid. So at this point we have 3 different subsets to the 24 students who received federal aid. And we need to think about, how should I draw these 3 subsets in the universal set? So the first question is, should the subsets overlap, and if so, which ones? Now, what does this, highlighted in purple, tell us about how we should draw the Pell Grant circle compared to the work study in the top circle? Since those with Pell Grants had no other federal aid, I need to make sure the circle that represents the Pell Grants is completely separate. So this is my P. Now we know that the work study and top students had overlap because 2 students had both work study and TOPS. So those 2 circles should overlap some. So I can draw these anywhere so long as they overlap. So let's let this be our work study, this be our TOPS. Okay, and then as we draw, or as we label in how many students were in each, remember the key idea that you always go to the most restricted sections first. So in terms of the most restricted sections, I would say the students with Pell Grants and the people overlapping the work study and TOPS are the ones we'd want to address first because those are given very specifically. We know that if you had a Pell Grant, you had no other federal aid and 5 students had Pell Grants. So right now, I'm going to label on the interior 5, and what I'm saying here is there's 5 students in the Pell Grant list. Not that 5 is an element of P, but 5 is counting the number of students who have the Pell Grant. Okay? From the information given, how many students have both work study and TOPS? They said 2 had work study and TOPS. So I'm going to write there's 2 students in this intersection. Now, we did have the information that 14 students participated in the college work study program. However, the work study program is made up, it's this entire circle, but notice the circle is sectioned into 2 pieces. This piece is the students who have work study but not TOPS. This section is the people who have work study and TOPS. Now, the entire circle accounts for 14 students because we know in all 14 students have the college work study. However, we've already accounted for 2 of the students, the 2 students who have both work study and TOPS. So if there's 14 overall and we've already accounted for 2, how many students belong in this section that is work study alone? 14 minus 2 should give us 12, which are work study only. So I should list out 12 students here. Now we need to determine, of the total students who had TOPS, 2 of them shared it with work study, and then the remaining TOPS students had TOPS without work study. So we were told at the beginning that 4 students had TOPS. How many students have we already accounted for within our TOPS circle? 2. 4 in total. So that means there's 2 students left who have TOPS but not work study. And this is why it's very important that you deal with the intersection first, because unless you deal with the intersection first, you're not going to properly label how many students only had work study or how many students only had TOPS. Okay, now add this together. How many students were in our universal set? 24. However, we have so far only accounted for 5 plus 12 plus 2 plus 2. We've only accounted for 21 students. So we know the remaining 3 students must be students who said yes to the question of financial aid. However, they do not have a Pell Grant, they don't have a work study, and they don't have TOPS. So the remaining 3 students must be in this exterior section that does not include the P, W, or T. So after you've filled in the separate subsets, you always need to add up and see, are we at the total that I was expecting? We expected 24 students, we've only listed 21. So the remaining 3 students must be part of the universal set, but not part of the listed subsets. So in this section, the majority of your time for these problems should be spent on drawing a correct Venn diagram and correctly understanding the information given and labeling all the subsets without overcounting. Now that we've drawn our Venn diagram and it's clear, let's move on to answer the questions asked. Okay, so remember at the very beginning we surveyed 48 students and we just asked them initially the question, do you have federal aid? 24 said yes, 24 said no. Of the 24 who said yes, we asked them follow-up questions like, do you have a Pell Grant? Do you have TOPS? Do you have work study? And we had the information. However, we know the number of students who had no federal aid was the original 24 students who said, I don't have federal aid. Now, how many of the students surveyed had more than one of these 3 forms of aid? So look at your Venn diagram. Who are the students who have more than one of the Pell Grant, work study, or TOPS? Visually, we can quickly identify that would be the students in our intersection, of which there were 2. How many students had federal aid? So they said yes to federal aid. They're in our universe of discourse. So they're somewhere in this rectangle. However, they did not have federal aid that was one of the 3 forms of Pell Grant Work Study TOPS. Think, who's represented by that description? These 3 students, because they're in our universe of discourse, which was the students with federal aid. However, they're outside of the Pell Grant Work Study or TOPS subset. So 3 had federal aid other than these 3 forms. Now, we need to interpret the next one carefully. When they say TOPS or work study, that's translated to the number of individuals in the set that's represented by T union W, because the word or becomes the union symbol. Now, in terms of the set T union W is all of this. So to count how many people are in that group, we would say 12 plus 2 plus 2, that's 16. So the answer here should be 16. Now briefly, if I had not drawn my Venn diagram and I was just basing my answer on the original survey information, so pretend we did not have this information. How would you have answered if you were just looking here, TOPS or work study? Probably students would have often made the mistake of saying 18, 14 plus 4. However, by saying 18, the reason that's off is because imagine we ask the students who has TOPS or work study. 14 people said they had the work study, but of those 14, 2 of them also said they had TOPS. So those 2 students who had both are counted in this number and in this number. So those 2 students are counted twice, which is why whenever we added these 2 together, we got the answer 18. That's off by 2 because you were counting the same 2 people in both locations. That's why it's so important that we write the Venn diagram and we correctly identify not only how many students had work study and TOPS, but how many students had both, so that we could correctly add up the number without double counting for their union. So take a moment and look at our Venn diagram and think, how would you answer the question exactly one of these 3 forms of aid? So how many students had exactly one of either Pell Grant, work study, or TOPS? Pause the video and attempt on your own, then unpause to check your work. So the amount of students who had exactly one of the 3 forms of aid are anybody who had the Pell Grant because they had only one type, these 12 who had only the work study, plus these 2 had only the TOPS. So 5 plus 12 plus 2, and that would give us 19. Now our final question is, how many of the students had no more than 3 of these forms of aid? So the first thing that we must do is translate, what does this phrase no more than 1 mean? No more than 1 is kind of an indirect way of saying something. What would be the direct statement? If you say no more than 1, that means 1 is okay. But also, if it's no more than 1, you could be less than 1. What number is less than 1 is 0. So no more than 1 means 0 or 1 of the TOPS, Pell Grant, or work study. So how many students had 0? So this is going to be the number of students without the TOPS, work study, Pell Grant, plus the number of students with exactly 1. Now we already identified the number of students with exactly 1. The number of students with exactly 1 is 19. Now, of the 48 students surveyed, we need to figure out how many had 0. So they did not have TOPS, work study, or Pell Grant. And this question is a little bit more nuanced. It's not just these 3. Definitely these are 3 students who did not have Pell Grant, work study, or TOPS. However, Also, the 24 students who initially said, I have no federal aid, would be considered to not have TOPS, work study, or Pell Grant. So the number of students who had none of the TOPS, work study, or Pell Grant is the 3 students who had another form of financial aid, plus the 24 students who had no federal aid, which will get us 36 students in all. And that would be a total of 46. Another way to think about this problem is when we say no more than one, what are we excluding? We want to say everything except if it's no more than one, the most we had was 2 of those 3, except those with 2 forms of the aid. So everything is all 48 students surveyed minus the 2 students who we know had both work study and TOPS. That's 2 of the 3 forms of aid, which would also get us to our answer of 46. So for some of these problems, there might be one way to do the problem and another way to do the problem if we just think about it from a different direction. No more than one is the same as 0 plus 1, or in this particular case, since the maximum number of overlap was 2, it was everything minus the piece that we don't want. So let's look at our next example. Suppose we run a small construction company and we're building multiple homes at a time. This week's work can be split into 3 different jobs: hanging drywall, which will represent with D, installing roofing, which will represent with R, doing electrical work, which will represent with E. Now imagine at the beginning of the day, we have the 9 workers at the construction company. And if we're trying to identify how many individuals can do each type of job to maybe get the jobs done most efficiently, we have the 9 people, so imagine 9 people lined up, and we say, okay, raise your hand if you can do drywall. 6 of the 9 people raise their hand. Next, we say, okay, raise your hand if you can do roofing. 4 people raise their hand. Now, we say, raise your hand if you can do electrical. 7 people raise their hand. Now, as we were watching that unfold, we realized, oh, quite a few people raised their hand for multiple things. So we next asked the more specific question, or we kept track as it was going on. How many people can do drywall and electrical? 5 people said they can do both. And then we said, how many can do roofing and electrical? 4 said they could do that. And then we asked the question, okay, how many people can do drywall, roofing, and electrical? 4 can do all 3. So what we need to do is we need to draw a Venn diagram that will clearly show to us in a very nice visual representation exactly how many workers have certain skills or groupings of skills. Now, from this statement, we know we're going to make our universal set the 9 workers at the construction company. So we draw our large rectangle. Remember, you need to give yourself plenty of space so that the writing isn't cramped. And we know that there's 3 subsets mentioned: the drywall, roofing, and electrical. Now, anytime we think about putting the subsets in the Venn diagram, we first ask ourselves, do I have information given that tells me should my certain subsets overlap at all? Based on this, think about how should you draw your 3 subsets. If we know that there are individuals who can do all 3 skills, we need to make sure we draw all 3 of our subsets overlapping. So I have the overlap, and we try to draw the subsets large enough that there will be plenty of space, and then we just label drywall, roofing, and electrical, though it doesn't matter which circle you label each one, so that we can all be doing the same work and it won't be confusing if you reference mine. Let's label them in the same way. Let's call this drywall, roofing, and electrical. Now, in terms of, and this is our universal set, of course. In terms of labeling a Venn diagram, we always go to the most restricted section first. Think, what section do you have to meet the most qualifications to belong there? In this problem, it would be this one, because in order to be in this section, you have to be able to do drywall, roofing, and electrical work, because you're where all 3 of the subsets intersect. How many individuals can do all 3 of these skills? 4. So the first thing we say is there's 4 individuals in this particular qualification. Now, next we move out to the next most qualified individuals. or not the most qualified, but who have the most skills listed. And we see it would be the people who have just drywall and roofing, or the people who have just drywall and electricity, or the people who have just roofing and electrical. So we need to figure out how many individuals go in each of these three sections that represent exactly 2 skills listed. So let's begin here. How many individuals were said to have drywall and roofing? Or sorry, I guess we didn't have drywall and roofing mentioned. As I looked, we only had drywall and electrical, roofing and electrical. So let's deal with this first, and then hopefully everything else will come and unfold as we work through it. So this is from the intersection of drywall and electrical. We know 5 people can do drywall and electrical. And keep in mind that the amount of individuals who can do drywall and electrical is actually this entire section made up of 2 parts. The section over here is the individuals who can do drywall, roofing, and electrical. But since they can do all 3, it also makes sense that they can do the 2 that we're interested in, right? Drywall and electrical. So altogether, the total in here is 5. We've already accounted for 4 of those individuals. So how many individuals can do exactly just drywall and electrical, but not roofing? 5 minus the 4 already mentioned is 1. Okay, similarly, figure out how many individuals can do both roofing and electrical based on this information. So in all, 4 individuals we were told could do both roofing and electrical. However, we already have 4 individuals listed as part of the roofing and electrical overlap. It just so happens that the 4 individuals who can do roofing and electrical can also do drywall. So there's no individuals who can do only roofing and electrical. So what we'll do here is we'll put a 0 in order to make it clear that we've dealt with this section. There's no individuals who have only these 2 skills, but the 4 people who can do roofing and electrical also can do drywall. Now we notice we weren't given direct information about the number of individuals who can do drywall and roofing. There was no so many can do both drywall and roofing. So what that means is we'll be able to figure out that information if we carefully look at the rest of the information that's given to us. So let's look. 6 of 9 can do drywall, 4 can do roofing, 7 can do electrical. If you have missing pieces, always go to what has the lowest number because that will probably be the easiest to account for. The roofing. Visualize what entails all of the people who have the skill of roofing. It would be this entire circle. Now, in this entire circle of the skill of roofing, how many people have already been accounted for? 4. But in all, only 4 people can do roofing. So the remaining sections that show roofing skills can have no more people listed in them. So the only people who can do roofing can actually do all 3 skills, which is why we'd follow up with saying there's 0 people who have the skill of only drywall and only roofing. And there's 0 people who only have roofing as one of the 3 skills mentioned. So we've dealt with our roofing criteria. Next, let's look at the number of people who can do drywall. We know that would be anybody in this circle. Now think to yourself, how many individuals have already been accounted for in the skill for drywall? 1 here, 4 here, so there's already been 5 individuals accounted for in drywall alone. The remaining section that we have to count would be those individuals who have, of the 3 skills listed, only drywall. We already have 5 of the 6 listed, so that means there's only 1 remaining here. So we've dealt with drywall. Similarly, take a moment to think about how you would complete all the individuals who have the skill of electrical. Pause the video, reread the problem if necessary, and then unpause to check your work. So we know that 7 individuals have the skill for electrical work. We have already accounted for 5 of them. So we have 5 already accounted for. There's 7 in all. There's only 1 space left over. So the remaining number that should go in this space is 2. So we've carefully working from the most restricted sections, working our way out. We have dealt with anybody who raised their hand that said they could do drywall, roofing, or electrical. Now we know in total there's 9 workers. So the next stage that we have to do is we have to count and see, does anybody belong to this outer section, in which case they did not raise their hand for drywall, roofing, or electrical. To do that, you add all the values together. So we have 1 plus 1 plus 4 plus 2. And that will give us 8 workers accounted for. There were 9 workers surveyed, so that means one of the workers has a skill other than drywall, roofing, or electrical. So now that we've used our survey information to make a clear Venn diagram that gives us a visual representation of exactly how many workers have which skills and what is the overlap between those, we can answer these questions. So again, remember, most of your time is spent drawing a correct Venn diagram. So how many workers have exactly 2 of the 3 skills? So that means they have just drywall and roofing, just drywall and electrical, or just electrical and roofing. The only individuals who would fit this criteria would be in these 3 sections, of which there's only 1 individual listed. So the answer to this is 1. How many individuals have none of the 3 skills? Look at the Venn diagram. 1 individual does not know the drywall, roofing, or electrical, but has some other skill. So there's 1 individual with none of the 3 skills listed. Next up is how many have no more than 1 of the 3 skills. So in this particular problem, there's 3 possible skills, and we want how many individuals have no more than 1. So the phrase no more than 1, in this context, since there's 3 skills possible, means we're okay with 1 skill, right? Because you just don't want to be more than 1. But you're also okay with less than that. So what's less than that? 0 skills. So we're saying what's the number of people with 0 of either drywall, roofing, or electrical, plus the number of people with 1 of the drywall, roofing, or electrical. So in that case, the number of individuals with 0 of the 3 skills is 1, plus the number with exactly 1 is 1 plus 2 plus 0, so that's 3. That will get us 4. Now another way to do this exact same problem is to say, well, if we want no more than 1, then what do we want to exclude? We don't want people who have 2 or 3 of the skills. So what we could do is we could take all of the workers and subtract the pieces that we don't want for this question, which is the number of people with 2 of the drywall, electrical, or roofing, minus the number of individuals with 3 of the drywall, electrical, and roofing. So this is just another way to do it. All the workers together is 9, minus the individuals with 2 skills is 1, plus 0 is 1, minus the individual with 3 skills is 4 of those. Altogether, 9 minus 1 minus 4, 9 minus 5 is 4. So we get the same answer either way. Probably one method appeals to you versus the other. Just feel free to use that as you work similar problems. Now our next question is, which skill is common to the greatest number of workers, and how many possess that skill? Now in this case, we're just interested of the 3 things listed, drywall, roofing, electrical, what was the maximum number of individuals who raised their hand? And for this, we could either look at the Venn diagram, or this is direct enough we can just look at our survey results. Of the 3 skills that were directly asked, the most individuals who raised their hand was the 7 for electrical work, so we would say 7 electrical work, and the number of individuals was 7. Next, we are going to introduce a fact and an idea that we've used without specifying it in previous examples. It's something that we've thought through, and now we're just putting it into mathematical notation. So realize this is an idea that we've already discussed, just without the notation attached to it. Do you recall from previous lessons what this symbol would represent? Remember, in parentheses capital letter means the number of elements in that set. And one of the main things that we want to learn how to do is to read mathematical notation, because if we can't read it and we don't know the ideas attached to those symbols, we'll have no way to work the problem. So let me give you a moment to read this mathematical notation from left to right. Think about how you would phrase it. Okay, I would read it as the little n we know is the number. So the number of elements in this set. What is this set called? It's A union B, which I know is all of the elements in A plus all the elements of B in a Venn diagram that looks like the number of elements in A union B would be found in this section, the overlap, or all of A plus all of B. Okay. So continue reading from left to right. So the number of elements in A union B is equal to, so they're telling me a relationship. I could find this by taking the number of elements in A plus the number of elements in B and then subtracting the number of elements in A intersect B. And I know A intersect B to be only those elements that are in A and B. Let's continue to write out the Venn diagrams of each of these, where A would be, where B would be, where is A intersect B. So we know A is all of this, B would be all of this, and then A intersect B would be their overlap. So we'll read the statement once more, and then we'll kind of make sense of it, and pay attention to the Venn diagrams as I read through. The number of elements in A union B, which that part of the Venn diagram is highlighted in blue, is equal to finding the number of elements in A by A plus the number of elements in B, and then subtracting the number of elements in their intersection. Now let me zoom in on these diagrams. Keep in mind, whenever I count the number of elements in A, I've counted the overlap, correct? Because that is part of A. And when I count the number of elements in B, what do you notice I count again is the overlap, because that's part of B. So the idea behind this fact written out in mathematical notation is that by counting A and by counting B, you've actually counted this 2 times. So you've overcounted. You've counted the same elements in 2 different locations. So to correct for that, if you've counted something 2 times, you should have really only counted it 1 time, which is why we then subtract 1 count of the oversection. And that will correct us to saying, okay, I'll have exactly this portion plus exactly this portion plus their overlap without being overcounted gives me exactly A union B. So if I know what the number of elements in A and B is right off the bat, that's great. But if I'm only told how many elements are in A, how many elements in B, and how many elements are in their intersection, I can use this formula to find the total number of elements in A union B. So let's look at this next example, keeping this in mind. Find the number of elements in set A if you have the following information. The number of elements in their union is 22. The number of elements in their intersection is 8. And the number of elements in B by itself, or just B, is 12. So if we set up using this formula, we know the number of elements in A union B is 22, but that means that's equal to the number of elements in A, which is what we're looking for, so I just write that down. I don't know it, I'll have to find it. Plus, the formula tells me I add the number of elements in B, which was said to be 12, and then I must subtract the number of elements in A intersect B, which we had from the formula, or the information given is 8. Now, this becomes 22 equals n of A. 12 minus 8 is 4. So it's saying, what do you add to 4 to get 22? Of course, if I want to figure this out another way, I could subtract 4 from both sides to isolate n of A. And either way, I would get the number of elements in A to be exactly 18. So we can use this formula not only to find the number of elements in A union B, but if we have 3 of the 4 pieces of information, we can fill it into the formula and then isolate to find the missing piece. So in our next example, we're asked to draw a Venn diagram and then use the given information to fill in the number of elements in each region. Okay, so just to practice, if you could read this to yourself, left to right. This would be the number of elements in our universal set is 43. So the total number of elements under consideration is 43. The number of elements in A is 25. The number of elements in A intersect B is 5. And the number of elements in B complement is 30. Now, we have our universal set mentioned, and we have subsets A and B mentioned. And I know in particular that they should have overlap between them, so I'm going to draw my general Venn diagram then. I have my universal set. We know in all there's 43 elements there. I know I have element A and I have element B, and I need to draw them with some overlap because I know particularly within this overlap is 5 elements. So we've dealt with that piece of information. Now, again, whenever you're labeling either elements in a Venn diagram or the number of elements in certain regions of a Venn diagram, which is what we're doing here, you go through like the most restricted regions and work your way out. So we've already dealt with the most restricted region, which is elements in both A and B. There's 5. So now we're going to turn our attention to the number of elements that were just A, and then next the number of elements that were just B. Now we know that altogether the number of elements in A, which is this entire circle, is 25. We already have 5 listed, so how many should be in just A alone? 20. Good. Okay, so next up we'd like to talk about how many elements should be in B. However, I don't have information that just tells me the number of elements in B is this. What I have instead is the number of elements in B complement. Now I'm going to shade in pink what would be B complement. B complement is everything outside of B. So you trace B as a circle, and then you shade everything outside. And the reason I'm trying to make this clear, maybe on a sketch off to the side, not on the original paper, is I need to understand what regions comprise B complement, because in all there's 30 elements across those regions. So in this pink region, there are 30 elements. And hopefully we can see this pink region is basically separated into 2 pieces. The first piece are those elements that belong to only A, not shared with B, of which there's 20. And the second piece is the part of the universal set that's outside of A and at the same time outside of B. So there's 2 pieces in all. If you add the number of elements in each of these 2 pieces together, you get 30. We already have 20 of them accounted for. So how many would remain in this outside region? What would that be? 30 in all, minus the 20 already accounted for, tells me there's 10 elements in the universal set that are not a part of A and they're not a part of B. So that's how I've used the B complement information. Now the way we're finally going to get our last remaining section that we didn't have direct information about is the part of B that's just B, not shared with A, is we know in all there's 43 elements. And of all the sections, we have everything except the number of elements in B, so it would make sense that if we add together all of these and see how far we are away from 43, the missing amount would have to go in this section that we've kind of traced out in red. So let's see how many elements have we accounted for. So we've accounted for 20 plus 5 plus 10 is 35. We've accounted for 35. There's one missing piece, so 43 minus the 35 that we've already accounted for leaves me with 8. So there should be 8 remaining elements that are just a part of B, not shared with A. So this is a problem where we were given a lot of information, but particular pieces were missing. However, those pieces, if we go about solving the problem in a logical and using the pieces of information that give us the most and kind of working our way out, we'll be able to find the missing pieces. So what are the main strategies that we used here? First of all, we made sure that we could read all the notation and we kept in mind what everything represented. So whenever we saw B complement, if we didn't know how to visualize that perfectly in our head, we would off to the side shade a Venn diagram of what sections make up B complement so we could understand what sections when added together have 30 elements. So make sure you understand the notation. Work off to the side if needed to help visualize. Next, we used the idea that I should fill in the most restricted information first if I've got it. So since they told me about A intersect B, that's definitely the most heavily restricted region, so we should immediately put that there's 5 individuals there. Next, I know that the most restricted regions that remain would be the section that's just A, not part of B, and the section that's just B, that's not part of A. How do I know which to deal with first? Is I had direct information about A, I did not have direct information about B. Then once we found the direct information about B, or A, we said I could find the only 2 things that remained were just B by itself and the universal set. And then we use the remaining information by understanding what the complement looks like to isolate those piece at a time. So just remember, if you're given various information but some are missing, there will be a way to figure out what's missing if you go about things in a careful manner. So as always, if you have questions, don't hesitate to reach out. I'll be happy to answer them. And we'll see you in the next video.